can be said to be certain except death, taxes, and the law of gravity. Those who have studied physics at a higher learning institution know that gravity is settled science. It meets all the scrutiny of the scientific method. But does it? Nikola Tesla, arguably the most underrated scientific mind of all time, did not believe in relativity or, by extension, gravity. His quote on the topic: "Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality." Keep this quote at the forefront of your mind as we navigate through the four evolutionary phases of gravity. Sir Isaac Newton published Philosophiae Naturalis Principia Mathematica in 1687. According to Newtonian mechanics, gravity is an assumed force between two objects based on mass and distance of separation. This bears repeating. Newton assumed the force, and although Newton established clockwork-like equations that provide precision results for measuring motion on Earth, he still considered his work on gravity a failure for not being able to prove the gravitational force or any force. By the late 1800s, many scientists found error in Newton's gravitational theory as applied to the universe. Most well known of these errors is with the movement of Mercury. Newtonian mechanics cannot explain Mercury's precession around the Sun. By 1915, German-born theoretical physicist Albert Einstein believed he had fixed the errors in Newton's work with his theory of...
Now, I trust Nikola Tesla because I did a fucking report on him not too long ago in my school. Wrote an essay about him, watched a bunch of documentaries, even though I know it's not all the information I should know, and it's what they're just giving me. But he definitely is the most underrated scientist of all time. Like, he made one of the greatest discoveries, and they wouldn't continue his work because he would have been able to make free energy for everybody. But nothing can be free in this life, can it? Everything revolves around the dollars because you're slave to the dollar bill.
Relativity. He theorized that gravity is what happens when space and time is curved or warped around a mass such as a star or a planet. Thus, a star or planet would cause kind of a dip in the space, so that any other object that came too near would tend to fall into the dip. Einstein basically explained how gravity is more than just a force, it is a curvature of the space-time continuum. Not only did relativity breathe new life into Newton's gravity, but it also shored up the collapsing heliocentric model after its very foundations were eroded by a series of 3 experiments. The Michelson-Morley experiment, conducted using an interferometer, clearly demonstrates the Earth is motionless. The Michelson-Gale experiment detected the ether passing over the surface of the motionless Earth. And Airy's failure, which demonstrated that it is the stars moving relative to a stationary Earth, and not the fast-orbiting Earth moving relative to the comparatively stationary stars. The results of these 3 experiments were explained away using a fundamental feature of relativity, more specifically, the principle of the constancy of the velocity of light. This principle posits that light travels away from a source at the same velocity relative to the source, whether the source is moving towards the light or away from it. The book, Fabric of the Cosmos, provides an easy-to-follow example of this fundamental feature. Bart Simpson and Lisa Simpson are conducting an experiment in which Bart uses a 500 million mile per hour skateboard to chase after a beam of light. While Bart is chasing the beam, Lisa is observing the light to be speeding away from Bart at 170 million miles per hour, which makes sense since Bart is going a constant 500 million miles per hour, the speed of light is a constant 670 million miles per hour. 670 minus a 500 equals 170 million miles per hour. When Bart returns from his trip, he tells Lisa that although he was moving at 500 million miles per hour, the light was still speeding away at a constant 670 million miles per hour, not 170 million, which from Lisa's viewpoint, the light was speeding away from Bart at 170 million miles per hour. In 1913, French scientist Sagnac conducted a simple experiment to test the principle of the constancy of the speed of light. Sagnac's apparatus was comprised of a turntable, light emitter, splitter, mirrors, and a photographic plate. A beam of light is sent through the splitter, splitting the light into two beams, which are then passed in opposite directions around the table between mirrors, completing their equidistant journey at the photographic plate, arriving at the exact same time. If light travels the same speed in all frames of reference, then spinning the table should not change the arrival time of the two beams of light. Sagnac rotated the table and not only discovered that one beam arrived prior to the other, but also that he was able to calculate the arrival times based on the rotational speed of the table. This proved unequivocally that the principle of the constancy of the velocity of light is erroneous, and therefore completely obliterates Einstein's theory of relativity. More recently, Cantor has demonstrated the same results as Sagnac with a similar apparatus. Acknowledging the validity of the Sagnac effect experiment would vindicate Michelson-Morley, Michelson-Gale, and Airy's failure experiments. Thus, the Sagnac effect was simply ignored and swept under the rug by the scientific establishment. Even after burying the results of the Sagnac effect, relativity was still not out of the woods yet. In the 1900s, astronomers identified a problematic discrepancy in Einstein's gravity while measuring the rotational speed of galaxies. More specifically, the outer regions of the galaxy were orbiting around the galactic nucleus at a much faster pace than predicted by the model. In fact, galaxies are rotating so quickly that according to Einstein's relativity, they should be flying apart. Once again, gravity is in critical condition and requires life support.
This should be making a lot of sense. It's all about scientists. All this other bullshit. You still think your ball going through space is an accident. That's not the case.
Physicists immediately began to theorize the dark matter solution to this rather large conundrum. Over time, dark matter has become the widely accepted answer. So what is dark matter? It is the universe's mass which doesn't emit, absorb, or reflect light. In other words, it is invisible and cannot be measured. Physicists know it exists only because it is required for gravity to work. You are probably thinking that dark matter is a tiny mathematical plug necessary to fix a minor rounding error in the model. This would be incorrect thinking. In order for Einstein's gravity model to work, dark matter must make up 85% of the known universe. Over the last 2 decades, the dark matter model has been failing important empirical tests. Astronomers have found less dark matter at the centers of galaxies than what the model suggests they would. The discrepancy is even worse at the cores of the universe's tiny dwarf galaxies, which have few ordinary stars but lots of dark matter. In 2011, due to the discrepancies in the current dark matter model, physicists began adopting a new dark matter model. In the new model, dark matter exists in a dark sector, somewhat parallel to our light sector, but detectable only through the way it affects gravity. According to James Bullock, physicist at the University of California, we are confident that it is there, that it has mass, and that it tugs on itself and other things via gravity. That's about it. While dark matter has a gravitational tug, it doesn't interact with normal matter, the stuff that makes up you and me, in a very intense way. It doesn't shine, it's invisible, it's transparent, it doesn't glow when it gets hot. To summarize the evolution of gravity, it is an assumed, unproven force injected with erroneous relativity, requiring an 85% plug of an invisible, immeasurable matter that exists in a different realm. At best, gravity fails to pass the scrutiny of the scientific method, but more accurately,